So my stopwatch is here. We'll hit this for 2 minutes. Quickly, let me turn off the windows quickly before we have air interference. So time start now. We will hit it for 2 minutes. We have spent 1 minute already. So in the next 1 minute, so what will happen here is that this metallic object will gain heat energy here, but the moment we transfer this guy to this beaker to gain energy, heat energy at theta1, theta without the subscript, theta, and to lose that energy, that heat energy from theta to theta2, and the water will gain the heat energy from theta naught to theta1. That sounds strange. That is the principle of mixtures. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 minutes done. Oh, you can hear that sound. So we drop this gently to avoid cracking of this beaker. And then I'll quickly off my lights and then use the stirrer to stir this to have a uniform distribution of the heat energy into the system. And then I will record the maximum temperature. The varying variables here are the volume of the water and the temperature. The trend we are going to have in this experiment is an increase-decrease trend. So if you watch here, the volume, the temperature, theta is 40 degrees Celsius. Our theta is 40 degrees Celsius. So the maximum temperature recorded here when the volume of water was 150 degrees Celsius, mass of water 150, volume of water 150 cm cube, mass of water 150 gram, at initial temperature theta and 28 degrees Celsius. 28 degrees Celsius. Sorry, our table of value was omitting something here. I'll quickly correct it. This is theta 1. So I'll quickly effect the correction / degrees Celsius. And then here is theta 1 minus theta 2 / degrees Celsius. So corrected. So here is 40.00. This is 40.00. So how do we get theta? Theta is equal to theta 1 minus theta. Theta 1 minus theta naught. So we'll say 40 minus 28. Our answer is 12. We have 12.00. Our theta, which is equal to theta 1 minus theta naught, is 12.00. So we'll repeat this experiment we are done with this water right now. We remove this mass. We will discard this water back to this place. Repeat the procedure for another volume of water. This time we are going for 200 degrees Celsius. So look at the table of value quickly. This is it. We have 150 cm cube. We have mass 150 gram. Initial temperature 28 degrees Celsius. Theta 1. This is degree Celsius. Theta 1 / degree Celsius 40.00 degree. And then theta, which is equal to theta 1 minus theta naught, is 12.00 degrees Celsius. So right now we're running for 200. So we are measuring this volume of water again. What do you see? The volume of water is exactly 200. 200 at eye level. So we are going to pour it here. That's it. And then measure the initial temperature of the water again. Our initial temperature of the water this time again. Let's see it. The initial temperature of the water is still 28. So we record 28.00. 28.00. You can see that 28.00. So we'll lit up this Bunsen burner again and repeat the experiment. So we'll hit this guy for another 2 minutes. So let's start. So 5, 6, 7, 8, 9, 10. We transfer it here again. Can you hear that sound? Wow. We drop it gently to avoid cracking of this beaker. Then we off our Bunsen burner again. And then we stir it homogeneously to have a uniform distribution of the heat energy. And then also record the highest temperature. So let's quickly record the temperature. The temperature right now, this is 30, 31, 32. 32 degrees Celsius. 32 degrees Celsius is the temperature we have right now. Look at it there. 32 degrees Celsius. Yes, 32 degrees Celsius. So record theta 1 as 32.00, not 32. Please look at it quickly. That is it. 32.00. So we discard this water here as we did the other time. We discard the water. We do this time for the volume of water 250. 250. So this is It's not exactly 250, so we'll add it up a little bit. We'll add it up a little bit to make it 250. Yes, that's it. So this is exactly 250. So as usual, we'll turn it here. And then measure the initial temperature again. The initial temperature is roughly 28. Yes, it is still 28 degrees Celsius. Yes, it is 28 degrees Celsius, confirmed. So we record 28.00. Can you see that? 28.00 seems to be a constant. So we will hit this guy again for another 2 minutes. So I will lit up my bouncing burner here again and repeat this procedure. Yeah, that's it. So and here we are again. So I off this quickly and I gently lower it down and remove it up. And so I will stir it again homogeneously to get uniform distribution of the heat energy. I will stir it. And so get my temperature. This time our temperature reading is 35. It's 35. So write 35.00. So the first one was 32 minus 28. Our value was 4.00. And this one is 35 minus 28. Our value is 7.00. This seems not to be a good value, this particular 250. But if you can observe here, 12, this is a trend. So let us run it and finish, and then I'll tell you what the trend is. But as I told you, it is an increase-decrease trend. As the volume of water is increasing, the temperature will be dropping, that is, will be decreasing. So we discard this water once again, and we'll repeat the procedure. This time for 300. It is not up to 300, so we'll add it up a little bit to make it up to 300. A little bit more. Exactly 300. So we turn it back here. Initial temperature will still give us 28. we still give us 28, and that was it. We have 28.00. So we will heat this guy up again for another 2 minutes. So our time starts now. 7, 8, 9, and 10. So transfer it again. We drop it gently. We off the Bunsen burner. We stir it. And obtain the highest temperature. So the highest temperature here is the highest temperature here is 34. So record 34.00. That is theta 1. So 34.00 minus 28 will give us 6.00. So this is our table of values right now. This is it. So we run the final value, and then we're done with the experiment. We remove this mass gently and discard this water here. And then I will measure the final volume of water. This is 350. Not up to 350. We'll increase it a little bit. Exactly 350. As usual, we will turn it here. The last lap of the experiment. And then we will measure the initial temperature of the water, which is always giving us 28. We don't need to waste time here. 28.00. Let's confirm. Yes, it is 28.00. Next line of action, heat this guy for another 2 minutes. And then we are done with the experiment. So I will lit this Bunsen burner again. Yeah. And heat this guy for another 2 minutes. So here we go again. 7, 8, 9, and then 2. So this is the last lap of the experiment. We off this. We are done with the experiment. Then we stir it homogeneously to get uniform distribution of heat energy into the system. We record the highest temperature. Our highest temperature recorded here is this is 30, 31, 30, 31, 32, 33. We have 33 degrees Celsius. So record 33.00. So 33 minus 28 will give us 5.00. So this is the table of values. You can see that the volume of water is increasing down, and the theta, which is equal to theta 1 minus theta 2, is decreasing down. 12, 4, 7, 6, 5. They are not good values, but there is an increase-decrease trend here. We'll manage this graph the way it is. Thank you. So the next thing we'll do right now is for we to go and plot the graph of the experiment and also do the other calculations. I wish to state here that I performed this experiment yesterday, and these were the values I got. These were the values I got in the previous experiment I did. You can see that we have 11, we have 5, we have 4. However, what we have here right now is not that too good. And I'm supposing that the error could come through the usage of the pair of tongue. Maybe the pair of tongue was a little bit delayed. The pair of tongue was a little bit delayed in the beaker, and the heat that was coming from the pair of tongue also added to the heat. In this experiment. So for this reason, these values are still correct values, but I am going to make use of these particular values. They are the same thing. These are the values I'm talking about. So thank you. Sorry, I've looked at it and I don't think the values are too bad. We have 12 here, we have 7, we have 5, we have 6. These are good values. We have 12, we have 7, we have 6, we have 5. So 4 is an off point here. So we are going to make use of this particular table of values. In fact, this experiment is a perfect one. So we have increase, decrease trend here. Thank you.